This is our second table building activity, and in this table building activity, we haven't given you a whole set of reactions. In this, we've got 3 reactions we're using to build an extended table. This table that we've used before had 1, 2, 3, 4 by 4. They did 16 reactions to find this. That's not a very practical way of sorting things out. So you can build a reduction half reaction table. And you'll remember that our strongest oxidizing agent goes at the top of the table, and our strongest reducing agent goes at the bottom. If we look at the previous table, you'll notice that bromine reacted with iodide. Well, bromine, the oxidizing agent, reacted with iodide, the reducing agent, and as long as the oxidizing agent is above the reducing agent, like this is a spontaneous orientation. But if I looked at silver metal reacting with copper 2 ion, you're going to see that silver metal and copper 2 did not spontaneously react. If the oxidizing agent is below the reducing agent, this is a non-spontaneous reaction. And that's important because in this, we're going to see that this reaction are spontaneous, but this one is not spontaneous. And so when I look at this, I look and see that this is going to be my oxidizing agent because it's going to gain electrons and be reduced because it's positive, this has no charge. So cobalt 2 ions becoming cobalt, this is my oxidizing agent. If it's spontaneous, the cobalt 2 ion must be above the indium solid, right? Because we said that a spontaneous reaction has the oxidizing agent above the reducing agent. This is spont. And that the oxidizing agent, if it's below my reducing agent, is non-spont. This was a spontaneous reaction. So my oxidizing agent is above my reducing agent. Once I know where they belong, I want to complete my half reactions. So cobalt 2 becomes cobalt solid. But indium is becoming indium 3. So this is becoming this, but the electrons go on this side. But if I'm writing this half reaction as a reduction, the indium is still the reducing agent, so I have to write it over here. So I've found that these two things are spontaneous, and then I complete the half reactions written as reductions. Cobalt 2 is a stronger oxidizing agent than indium 3. Then the next thing is my next reaction has to have one of these chemicals in it. And you'll see that cobalt solid is here. Copper 2, the oxidizing agent, is spontaneously reacting with cobalt. So if cobalt is my reducing agent, my oxidizing agent, copper 2 ion, must go above it, right? Because this is a spontaneous reaction. So it goes above it. Copper 2 plus 2 electrons makes copper solid. So this is the strongest reducing agent so far. This is the weakest reducing agent so far. This is the strongest oxidizing agent so far. This is the weakest oxidizing agent so far. So we've done 2 reactions. In our third reaction, it's non-spontaneous. And we have copper 2 does not spontaneously react with palladium. Palladium is a reducing agent. So palladium solid is going to be above the copper 2 because it's non-spontaneous, right? So the copper 2 non-spontaneously reacts with palladium. Palladium has to go above it. Now I'm not exactly sure which ion they wanted me to deal with palladium because they didn't show us anything in the products. But since it's copper 2 or palladium 2 is the more common ion, I'm going to say palladium 2 ion plus 2 electrons would make palladium solid. This is my strongest oxidizing agent to my weakest oxidizing agent. This is my strongest reducing agent to my weakest reducing agent, and that is how I develop an extended redox half reaction table. So they're always written as reductions, and it always goes from the strongest oxidizing to the weakest oxidizing, strongest reducing to the weakest reducing.